and the periodic table. And right now we're going to talk a little bit about kind of classifying matter, which we'll break down further later on. But we're just going to talk about how the periodic table is arranged. And because of its arrangement, there are some things that we need to know about it. And so first off, when we're talking about elements, elements are pure substances. And so when we say that they're pure substances, we mean that whenever we're talking about just an element, we consider it a pure substance because it's only that particular element. And with elements, these cannot be decomposed by chemical changes, and these are the building blocks of matter. Now, with elements, there are two big types. Elements can be what we call monatomic or what we call diatomic. Now, monatomic elements are the elements that a majority of the periodic table actually consists of. And so with our monatomic elements, these are ones that can exist just as a single atom. So if you think about the word mono, right, you think of single. So monatomic elements naturally are elements that exist as single atoms. So some examples would be something like sodium, which is Na, or calcium, which is Ca. So both of those are monatomic elements. Now, a majority of the periodic table is actually monatomic elements. Now, there are diatomic elements. Now, these diatomic elements are elements that exist in a molecular state, meaning it's two of the exact same atoms bonded together. Now, there are only 7 atoms that exist like this. And so when we say that these are bonded together, it means that these 7 atoms can't exist just as a single atom floating around. So if it's a pure element or it's a pure substance, it has to be bonded together. Now, these 7 elements, I like to call them the Hankelbriefs. And so the reason I call them the Hankelbriefs is because it's hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. So see how it spells out Hankelbrief? Now, all of these exist as diatomics, meaning that in their formula, it's not just H or O, it's instead something like H2 or Cl2. So if you have chlorine, it's not just single chlorine atoms, it's 2 chlorine atoms that are covalently bonded together. Now, elements themselves don't have a charge, but elements that do have a charge are what we call ions, which we'll talk about in a few minutes. Now let's talk about something else known as compounds. Now, compounds are also considered pure substances. And with our pure substances here, 2 or more different elements are joined together is how we end up making our compounds. Now, there are 2 different types of compounds. There's ionic and covalent, which you guys are probably familiar with. And so with ionic compounds, these are bonds that occur between a metal and a nonmetal. Now, aside from these, there are the covalent substances. And for covalent substances, these are bonds between 2 or more nonmetals. And so with this, the periodic table is actually divided up into several different ways. And so our ways of separating these include the metals, nonmetals, and our metalloids. And this is where it says C-colored periodic table. And so this is where we're actually going to take a minute. And the periodic table that you guys printed off, we're actually going to take a second and color it. And so, or at least highlight certain parts of it. And so if we're going to highlight certain parts of it, let's start off with our metals. Now, the metals that we're going to highlight include everything over here, everything through this middle section, So all of this, these are all of our metals, and then this bottom section. Now, in addition to these, there are some other metals that we need to label, and this is where we got to be a little bit more careful. So the other metals that we need to label include aluminum, gallium, indium, thallium, then germanium, tin, and lead, then antimony and bismuth. So those are what we have to label as our metals. And here we'll even label that really quick. So this is our metals. Now let's talk about some of our nonmetals. Now our nonmetals are over here, and this includes boron, carbon, all of these. Then we got to be careful, but it's chlorine to phosphorus, bromine and selenium, iodine, acetine, and then finally our last row from helium all the way down to radon. And so these are all of our nonmetals. So we'll label those nonmetals. And then we had that third group, the metalloids, and that happens to be pretty much what's right in the middle. And so our metalloids include silicon, arsenic, tellurium, polonium. And depending on who you ask, there are some people that include germanium in there and selenium in there. But ultimately, if you just know it as kind of that set, you'll be okay. All right, and so that's our metalloids, and you can label those with green. So metalloids. All right, so take a minute and color your periodic table so it has the sections labeled, or if you want, just draw arrows or boxes around stuff and label the boxes, whatever you'd prefer. But once you're ready, go ahead and unpause the video and come back so we can talk about our... All right, so let's talk about our classification of matter. Now, with our classification of matter, matter basically breaks down into two parts. It breaks down into what we call pure substances and it also breaks down into what we call mixtures. Now, with this, let's kind of talk more through our pure substances because that's kind of what we've talked about so far. So with our pure substances basically have three possible options. Pure substances could be elements. They could be compounds. Or the last thing is that they could be ions. Now from here, let's focus on our elements first. So elements, we had two types. We had our monatomic elements, which remember is a majority of the periodic table. And then we had our diatomic elements. Now remember, for our diatomic elements, these are that special list as our Hankel-Briffs. So these only include hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Now from here, if something is considered diatomic, that means that it's also considered a molecule. And so let's kind of just put that last little one on here. And so now let's talk about our compounds. Now the two types of compounds that we talked about, we had covalent compounds and we had ionic compounds. Now remember, our ionic compounds had a metal and a nonmetal. And then our covalent compounds had just two or more nonmetals. Now, when we're talking about metals, remember when we labeled all the parts of the periodic table, that would be where we would look. Now, if you're looking at a formula, you only have to look at the first element that's listed. If that first element that's listed is a nonmetal, that means it's automatically covalent. So let's just say it's something like H2O. So we have hydrogen and we have oxygen. And we know that H2O, hydrogen, is a nonmetal, oxygen is a nonmetal. Therefore, it makes it covalent. And so as we're looking at this, with classifying something as covalent, the other big thing that we have to do is we also classify covalent substances with the word molecules. Now, if it's an ionic substance, we actually just stop there and we call it an ionic substance. And then when it comes to our ions, ions are just ions. So there's no other way to classify them. We call them pure substances, then ions. Now let's talk about this other set that we haven't talked much about yet, which is our mixtures. Now, with mixtures, mixtures just in general are things that can be separated. So if you're talking about whether or not something is a mixture versus a compound, the idea is compounds are substances that are chemically bonded together, where mixtures, on the other hand, things aren't chemically bonded together. It's just kind of thrown together. And so with this, with our two mixtures, we have two big types. We have our heterogeneous mixture, and then we have our homogeneous mixtures. Now, when you're looking at these, our kind of way of deciding whether something is heterogeneous versus homogeneous is heterogeneous mixtures all look different. So these look different, meaning the parts are visible. So this is stuff like a salad where you can see the lettuce versus the tomato versus the croutons. Whereas if something is considered a homogeneous mixture, homogeneous mixtures are the same throughout. So a homogeneous mixture would be something like lemonade, where you have your water and you have your mix. So when they're mixed together, though, you can't see the mix versus the water. It's all blended together and it looks the same. So now that we've kind of gone through and we've classified our matter here, let's actually look at our practice page for today. And let's talk about how that actually works. We've talked about our classification of matter. Let's go through our first example here. So we have CaCl2. Now, one of the things that hopefully we notice here is that this is a chemical formula, meaning it's coming from parts of the periodic table. And so we have Ca, and immediately afterwards is Cl2. Now, the fact that they're written one after another indicates that this is bonded together. And so if it's bonded together, that means it's not a mixture, but instead a pure substance. And so that's the first label that this gets. Now let's talk about what comes after that. So if we're following our flow chart and we go through, we just labeled it as a pure substance. Then from there, it's an element, compound, or ion. Now, as we're looking at this one, hopefully we see that since it's CaCl2, it's two different things together. Now, we already said that they're bonded together, so that means that this has to be, just looked and we saw that this would be a compound next. So now, after compound, there it broke down into two parts. It broke down into either calling it an ionic compound or a covalent compound. Now, from compound and deciding between ionic and covalent, remember ionic compounds are between a metal and a nonmetal, and covalent compounds are between two nonmetals. So our tests, we only have to look at the first element that's listed, which happens to be Ca. And so we just go to our periodic table and find it. And as it turns out, Ca is right here. So remember when we colored it yellow earlier, we were labeling it as a metal. So that means that since calcium is a metal and it's bonded with chlorine, which we call calcium chloride, this actually is then, after a compound, we consider this an ionic compound. Ionic. All right, so that's the first example. So go ahead and you guys will spend some time working through the next couple examples. Once you're finished, feel free to double check the answer key. So hopefully you're ready to talk about names and charges of ions. And so with this, we have what we call monatomic ions. Now, with our monatomic ions, these are made from our single atoms. And when we make these ions, they had to have either gained or lost electrons. And so that's the big thing with this, is that it's all about the movement of electrons. Now with this, we have what we call the main block elements. And they consist of the following groups: 1, 2, 13, 14, 15, 16, 17, and 18. Now, with these groups, so this is groups 1, 2, 13, 14, 15, 16, 17, and 18, they all tend to form charges that are actually fall into a pattern. And so our group 1 forms a +1 charge. Group 2 forms a +2 charge. Group 3 is +3. Then group 14 is plus or minus 4. Then when it comes to group 15, this is -3, 16 is -2, 17 is -1, and 18, they actually don't form ions at all. So now let's actually talk about how this relates to our periodic table. And so on our periodic table, that does mean that in terms of what we're looking at as our groups, the groups are the numbers that go across the top. So this is like 1, this is group 2, and then as it continues on, it's 3, 4, 5, 6, 7, 8, 9, 10, 11, which happens to be copper down, and then 12, which happens to be zinc down. Now this is where we get into that first set of our nonmetals. So this is where group 13 is. So group 13, 14 is carbon down. Then group 15 is nitrogen down. 16, 17, and 18. Now what this means is that everything within group 1, we just talked about it being having a +1 charge. So that means that this group all forms +1. So hydrogen forms +1, lithium is +1, sodium's +1, potassium, rubidium, cesium, francium, they all form a +1 charge. Then in group 2, remember we labeled that as +2. So beryllium, magnesium, calcium, strontium, barium, radium, all of these elements only form a +2 charge. Now we skip this center section, which we refer to as our transition metals, and we'll talk more about those later. But then over here is where we come back to our nonmetals with boron, and boron is where it forms a +3 charge. Then carbon, and this is where it's plus or minus 4. Then from there, nitrogen and phosphorus. Now when we say, and this is where it gets a little bit tricky, because these negative charges really only apply to our nonmetals. So that means it really only includes phosphorus and nitrogen. Now the same is true for the rest of these rules. So as we go down, and so we got to fix that line a little bit. So that only includes really that set. And so I can make that line a little bit darker if it helps, so that way you guys can see and understand what is versus isn't charged with these last couple charges. Then Oxygen, sulfur, and selenium are -2. Fluorine, chlorine, bromine, iodine, these are all -1. And then finally, our last group, which is known as the noble gases, helium, neon, argon, krypton, xenon, radon, those all form a 0 charge. So take a second and actually go through and label the charges on there. You don't need to label the groups. Those are already labeled on your periodic table, but label those charges because that'll help you out with not only stuff later on today, but that'll help you out with what we're going to talk about actually tomorrow when we talk about naming ions. And so let's switch back now to our notes. And when it comes to our metallic ions, all of our metallic ions are what we call cations. Now, cations are positively charged ions. And if it helps, remember cations are positive. I know, it's my one good joke. Otherwise, metallic ions, when they become an ion, they actually keep the name of the element and then we just add the word ion at the end. So one example would be Na with a positive charge. So that's what's denoted here with this little plus sign. It's telling us it has a positive 1 charge. And so we look at the periodic table and we see that Na is sodium. So the way that we label this ion is just sodium ion. Now, if we look at our next one, the Mg+2, let's look in our periodic table and find magnesium, or Mg. And notice it's in that +2 column, so it always forms that +2 charge. And so when we're naming this ion, we don't just call it magnesium, but we call it magnesium ion. All right, now let's talk about, okay, well, this is all of our kind of positive charges. What about some of our negative charges? And so for our negative charges, remember, this is where we had all of our non-metals. So these are all of our non-metallic ions. Now these we call anions. Anions being the negative charge. And with our non-metallic ions, we actually change the ending. And so the ending of the element is actually changed to "ide." So that's why it's called like sodium chloride as opposed to just sodium chlorine. So one example happens to be Cl minus. And so remember, if there's no number there, it's just saying it's -1. And so if it's Cl with a minus, that means it's chlorine, but we change the ending to chloride. All right, well, now let's look at another one. We got P-3. So remember, the -3 should help you find it on the periodic table. It should be that -3 column. And when you look, hopefully you see that this is phosphorus. And so we change the ending of phosphorus to that "ide" ending, giving us phosphide. All right, and now let's talk about our transition metals. Now the transition metals on our periodic table is that center section. So everything within, we'll make a black box here, everything within our black box, these are all of our transition metals. And so we call them the transition metals because it's the transition between groups 1 and 2, and then all of our other main block elements. And so now let's talk a little bit about these because these transition metals are special. And so with our transition metals, the reason that they're special is because all transition metals, or almost all transition metals, can form what we call variable charges. And so since these can form variable charges, that means that their charges actually change depending on different situations. And so with these variable charges, it changes. So for example, iron can form both a +2 and a +3 ion. So since all of these elements can form 2 different ions, or sometimes even 3 or 4 different possibilities, in order to differentiate between these, we use a Roman numeral to indicate the charge when we're naming. And so just a kind of quick, in case you don't remember your Roman numerals, just a quick review. If we put our numbers here, so 1, 2, 3, 4, 5, and 6. And for what it's worth, that's all you should need to know, just because most elements can't form even a 5 or a 6 charge. There's only a few. And so in Roman numerals, 1, we just draw it as an I. 2 is II. 3 I's. Then 4 becomes IV. 5 is just V. And 6 is VI. And so when we're talking about naming, let's look at an example here. And so we have Fe plus 2. So remember, the plus 2 indicates that the charge is 2. Now let's go through and find Fe on our periodic table. And so as we're looking for it, remember, it should be in the center section here, and up, here it is, right in the middle. And so that happens to be iron. So now when we're going to name it, Fe with a plus 2 charge, since it's iron, we would label it as iron, and then the plus 2 in parentheses, we put our 2 Roman numerals. Then if it's Fe with a plus 3 charge, we just saw Fe is iron, so this is iron 3. And so this is how we have to label all of our transition metals in terms of their charges. Now, a couple kind of exceptions here is with this, although these aren't considered transition metals, we include in our rules here lead, which is Pb, we include lead, which is Pb, tin, which is Sn, bismuth, which is Bi, and Sb, which is antimony. And so anytime we're also naming with these, we should also use a Roman numeral to indicate their charge. Now, a couple exceptions to these rules include zinc, which always has a charge of plus 2, and silver, which always has a charge of plus 1. Now, one of the kind of ways that I like to remember this, if we're looking at our periodic table here, aluminum, because of where it is, it always has to form a plus 3 charge. So the way that I like to think about it is it goes 3, 2, 1. Kind of at a nice downward angle. So aluminum is plus 3, zinc is plus 2, and silver is plus 1. So that's a helpful little way to at least remember zinc and silver's charge. Otherwise, let's talk about our last kind of little group here in terms of naming. And these are the polyatomic ions. Now, with our polyatomic ions are any charged group of 2 or more chemically bonded atoms, but they function as just a single ion, meaning they're floating around bonded together. And so atoms and polyatomic ions are covalently bonded, but the ion as a whole forms ionic bonds with other ions, meaning that as they're forming these ionic bonds, it operates like a regular metal and a nonmetal, like we talked about earlier with our ions. Now, for these ions, you can actually find all of these on that commit to memory page. And so let's actually take a second and just kind of look at our commit to memory page. And so within there, here it is. Now, what you guys actually need to remember here, I wrote on the paper for you. And so in terms of the commit to memory, we have first on the left side, the silver and zinc. So remember, we just labeled those on our periodic table. I showed you guys a 3, 2, 1 Now, aside from that, these are all of our polyatomic ions. Now, at some point in the year, you're going to have to memorize these. Last school year, it was by September 23rd. And so expect something very similar about a month into school. You'll have to have this entire list memorized. So I would encourage you guys to start working on it now. And so this is all of the polyatomic ions that you guys are going to see. Don't worry, there are going to be some other ones, but you're not going to have to worry about memorizing them. So anyways, our example was hydroxide. And so if we look through here at our names, here's our hydroxide ion, which is OH minus 1. So let's go back and let's put that on here. So the hydroxide ion is oxygen and hydrogen bonded together, and together they form a -1 charge. All right, so that's that one. Now let's look at another one. So sulfite, or the sulfite ion. So now if we go back and we look for the sulfite ion, let's look through our list, and I think I passed it already. Oh, there it is, sulfite, SO3 minus 2. And so let's kind of take a second and look at that. So that is SO3 minus 2. And so now that we have this, now let's kind of go through and talk about what you guys should hopefully know after going through this. So some of the important highlights of this video. First, this is one of the big ones, is on your periodic table, you should have labeled the sections or the groups with their typical charges. So with our groups and their typical charges, you should have, in particular, the charges of groups 1, 2, and then all the way over here, group 3, 4, which remember when we say plus or minus 4, we're only talking about carbon and silicon. Then -3, which only applies to the nitrogen, phosphorus, and arsenic. Then -2, which is oxygen, sulfur, and selenium. And then -1, which is our halogens. So that whole group we can label as -1. And then finally, our noble gases was 0. So this is a very, very important part of kind of understanding our next topic, which will be writing out the names and formulas for ionic compounds.